All right, so today's lesson is still about quadratics, but you guys have noticed that the entire unit that we've done, like Monday, Tuesday, Wednesday, we haven't really done any math, right? We've done a lot of graphing, we've done a lot of drawing and things like that, but we haven't really gotten into the math. So now the second half of the unit is the mathematical part, like the algebra part. And so we're going to start with this lesson, but like I said, this unit isn't done. We're going to continue it on next week, next week when I see you. Today, what we're learning is a very important skill. It's a skill that comes up again in grade 11 and 12. Almost as important, not as important as factoring, but it's definitely up there. It's called completing the square. That's the name of it, completing the square. And the general idea is we're going to be taking an equation that is in standard form, and we are going to be changing it into something called vertex form. Now, these words may sound new to you, but they're actually not new. You have seen these before. Safir? You did it already? Yeah. Okay. Okay. Well, when we get to it, let me know if you get the same answer as we do. But you've done this before? Yes. Okay, that's good. That's good. That's good. Okay, good. Okay, so what is standard form? Standard form looks like this. Y is equal to ax squared plus bx plus c. Do you guys remember where we saw standard form before? Samira? Yeah, like the line stuff, right? Not the line stuff, after the line stuff. Even after that, remember when we were factoring? Remember when we talked about trinomials, like simple trinomials and complex trinomials? That is written in standard form. So an example of something in standard form would be like y is equal to 3x squared plus 2x plus 4. So remember when I would give you a question like this and I would ask you to factor it? Well, whenever I gave you a simple or complex trinomial, the name that we can give this type of equation is standard form. Where have you guys seen vertex form before? Najib? Yeah, just this week, right? We started learning about vertex form, and vertex form is really, really important because this is what you need to graph a parabola. Can you graph a parabola when something is in standard form? If I were to give you this equation, can you tell me what the vertex is? Can you tell me what the axis of symmetry is? Can you tell me what the maximum and minimum value are? The answer is no. We don't know how to graph a parabola from this form. However, if something was in this form, 2x plus 3 squared minus 8, could we graph a parabola from this form? Yeah, we know that this parabola has a horizontal translation, 3 units to the left, a vertical translation, 8 units down, a vertical stretch, and we don't even need to make a table of values or anything. We can just use our step pattern and really quickly graph this parabola. So what is the point? What is the purpose of today's lesson? Well, I can give you something in standard form. However, to graph it, we need to convert the standard form into vertex form because this is the form that we know to graph a parabola really easily. And the process of converting something from standard form to the very useful vertex form is called completing the square. Does that make sense? Kind of have an idea of where we're going? Okay. So I think we're going to do about 3 examples, and then there'll be a couple of challenge and then one going backwards. So as usual, I always say the first example may not make sense. It might be a little confusing. The second example might make a little bit more sense. By the third example, I do hope that you understand it, but it's a new concept. So be easy on yourselves. If you don't get it right away, don't feel frustrated or anything like that. Just give it time. For this concept though, you need to do like 20 questions for practice before you get really, really good at it. So if you expect to just do the examples and understand it, it probably won't happen. You have to do a bunch of different examples. It's kind of like factoring. All right. So I have the instructions over here. We'll read through them, and then when we actually do the question, hopefully it'll make a little bit more sense. So when we're completing the square when a is equal to 1, which means when that value in front of the x squared is a 1, here's what we're going to do. We're going to add and subtract the square of half the coefficient of x, confusing right now. We're going to group the perfect square trinomial, and then we're going to write the perfect square trinomial as a square of a binomial. I really don't like instructions in math that much. I feel like they don't make any sense. I need to see it being done. So if you're the same way, this probably is like just nonsense. Let's go ahead and try this question. Okay, so our question, I'm just going to rewrite it over here, is y is equal to x squared plus 6x plus 8. Okay, step number 1. We are going to group the first two terms together by putting brackets around them. Yep.
So we're going to convert the same form to vertex form, right?
Exactly. So we're trying to convert this into a form where I can then easily graph my parabola and I can answer questions about it. Because in this form, I cannot graph the parabola yet.
So what is it going to tell? Like, if you tell us where vertex.
Yeah, exactly. It'll tell you where the vertex is, the axis of symmetry, the maximum, minimum, and we can get a step pattern and all that stuff. Okay, so we group the first two terms together. Now, in this question, there is nothing in front of the x squared. So this question is actually quite easy. In question examples 2 and 3, you're going to notice that now we have numbers in front of the x squared. So we do a separate rule for those. Okay, so just keep in mind, this is our beginning initial question. It's a little bit easier. What you're going to do is you're going to look at the number that is attached to the x, and you are going to complete the square with it. So I'll walk you through the process nice and slowly so you can try to see what's happening. Okay, so I'm going to take this number over here, the 6, and I'm just going to go over to the side to complete the square. Okay, so what you do with this number is first you take that number and you divide it by 2. So whatever number is attached to the x, you take it and you divide it by 2. 6 divided by 2 is going to be 3. Good. And then you take this number and you square it. 3 squared is going to be 9. And this step right here that we have done, this is the actual completing the square part. I'll repeat it again. You take the number attached to the x and you divide it by 2. Then whatever answer you get, you square it, and that is the number we're going to be working with. So everyone needs to remember the number 9. It's going to be super important. All right, I'm going to try to color code as much as I can. So the next step, I'm going to rewrite the first two terms. So 6x squared plus 6x. And then do you see this number that we just calculated? By the way, this number, can it ever be a negative? Think carefully, Najib. Yeah, even if we put like a -6 and a -3, when you square something, it'll always be positive. So whatever number you get here, it has to be positive, right? Because when you square something, you'll always end up getting a positive number. All right, so you take this number and you add it on to this binomial that we have going on. And then you put brackets around the whole thing. I want a color that really stands out, and I don't think I'm going to put +9. There we go. Okay, so far you're with me. We took our number, we added it here, we put brackets around the whole thing. Samir?
So what about the
We're not done, so just stay with me. And then you are going to take that same number and then you're going to subtract it. Let's think about why that happens. Now, when we're, Hiroshi, go ahead. That's exactly it. So all we're trying to do is we're trying to convert from standard form to vertex form. We're not trying to change the values of anything. We're not trying to change the question. I still want both of the questions to be exactly the same. If I add a random 9, in math, you can't do that. You're not just allowed to randomly add numbers whenever you feel like it. So to balance out the +9, I have to subtract the 9 to make sure the actual value of it does not change. Okay, so the step is whatever number you get when you complete the square, you add it and then you subtract it as well. I like to add extra brackets, and hopefully this will make sense as we get through the questions. I'll try to explain my reasoning a little bit more, But once I'm done this, what I like to do is I like to add big, huge square brackets around everything. And like I said, for this question, it might not make sense, but for question number 2, you'll see my reasoning as to why I do this. Okay, and then we can't forget about the little +8. So I'm going to put the +8 all the way on the other side. Not confused? Okay, now the next step is we are going to look at the term inside the rounded bracket. And if you've completed the square correctly, you should be able to factor this and get 2 of the exact same factors. This, in other words, this term right here should be a perfect square trinomial. So let's check and see. And by the way, you do have to remember factoring. Factoring is going to come back here. So let's check and see if that is actually true. I have inside the rounded brackets, I have x squared plus 6x plus 9. Okay, a little review on factoring in case you've forgotten. What 2 numbers multiply to give you x squared? I heard it, x and x. Let's think of all of the factors of 9. We have 1 and 9, 3 and 3. Do any of those pairs of numbers add to give you a 6? Maggie? Yeah, +3 and +3. So I'm going to put a +3 here. And I'm going to put a +3 there. And what is it called when you get 2 of exactly the same terms, Safir? You can square it, but also I'm just looking for the term. This is called a perfect square trinomial. So you may remember this or may not, but this, I'll just put it in a short form, perfect square trinomial. And we can rewrite this so that it is x plus 3, all of it squared. And the cool thing about completing the square is whenever you're completing the square, whatever this term is, it will always factor to give you the same 2 terms. If it doesn't, you've done something wrong. You didn't pick a good number here. Because if you do it correctly, this will always factor to give you a perfect square trinomial. All right, so now I'm going to replace this x squared plus 6x plus 9 with my perfect square trinomial. So I'm going to replace this. And you can always do the work on the side, by the way. You don't have to do this factoring stuff in the question and it makes it too messy. So I want you to just do it on the side somewhere. And then here, I want you to write x plus 3, all of it squared. We've used up the +9, but have we used the -9 yet? No, so we need to keep that there. And we need to keep the +8 there as well. So really visually, all that's happened is this has now converted into this. Okay, the perfect square trinomial has been factored to give you a factor. Samira? Going. Okay, now how do we get rid of the square brackets? What we do is we take the number outside and we distribute it to everything inside. However, what number do we actually have on the outside over here? Krishna? It's just a 1. So when you multiply 1, does anything happen? No. So really in this question, you're not really going to do anything much. You're just going to open up the brackets. It's going to be x plus 3 squared minus 9 plus 8. And then in the final answer, we can just add the -9 and +8. So we're going to get x plus 3 squared minus 1. Shweta, you had a question? Shweta's like, this is the worst thing ever. All right, so why was this so important to do? Well, we now have our equation in Vertex form. And I guess this is kind of good review for what we have been doing in the past. In Vertex form, we can very quickly graph this and see what kind of graph we get. So what will our horizontal translation be? Brianna? 3 to the left. So I'm just going to approximate. I'm going to say, let's say this is -3. And then what will our vertical translation be? Yep. It's going to be 1 down. And so our vertex is going to be somewhere around here, -3, -1. Which way is this parabola going to open up? It's going to be open upwards because there's no negative sign. There's no stretch, but also I'm just sketching it. So when you're sketching it, you don't have a grid, right? You can't go 1, 3, 5. I just want to know the general shape. So the general shape of this parabola is going to be something like this. And the important thing to recognize is when it was in standard form, you had no idea what the shape would look like. You can't figure out the horizontal translation, the vertical translation, nothing. That's why we complete the square to get it into vertex form. So now it's super easy to sketch. I can even ask you questions like, what is the axis of symmetry? Even without sketching, you should know it's x is equal to -3. What is the minimum value? You should know it's y is equal to -1. So all that stuff that we were learning, here you go. All that stuff we were learning in our previous classes, now you can sort of put everything together in vertex form. So example number 2, I'm not even going to read all the instructions. We're just going to get right to it. It says rewrite the equation y is equal to 3x squared minus 12x plus 11 in the form y is equal to blah, blah, blah. This is just a fancy way of saying we want to convert it to vertex form. And again, we convert things to vertex form because it's a very useful form to help us graph our parabolas. When something is in standard form, it's essentially useless for us in terms of graphing. Okay, so I'm just going to rewrite this again over here. Y is equal to 3x squared minus 12x plus 11. What do you guys notice that is different in this question versus the first question that we did, Jennifer? Perfect. So a is not equal to 1. This first value is not 1. There's a coefficient. So we are going to now add an additional step to the steps we were doing before. Okay, step number 1, we're still going to group the first 2 terms together. By the way, if this was not in order, you would have to put it in order. So make sure it's always x squared, then x, then the constant. If I gave it to you jumbled up, first step would be put it in proper order. Samira?
So like when you're putting the brackets, you just put grouping the like, right?
When you're putting the brackets, you're just grouping the terms together.
Like the like term?
They're not really like terms. You're just grouping the term with the x squared and the x together. But they're not like because they have different exponents.
No, you like the ones that have that.
Yeah, sure. You put the x exactly. Now what we're going to do is we are going to factor out the coefficient that is attached to the x squared. We're not going to factor out the x, even though the x is common in both of them and it seems very tempting. That is not something we're going to do. All we're going to do is factor out the 3 so we can have the x squared all by itself. So what's that going to look like? Well, I'm going to take my 3 and I'm going to factor it out and I'm going to be left with x squared minus 4x. Take a second and see if this makes sense to you. Everyone get what I did? Okay. What is the purpose of this? I always want my x squared to be by itself before I start completing the square. So if you have a number attached to the x squared, factor it out from both of the terms, the first 2 terms, until the x squared is by itself. Samira?
So like your bracket.
So you guys remember in the first question how we completed the square? Which number do we pick to complete the square with? In other words, you know all that stuff we did where we divided by 2 and squared it? I had told you it's always going to be attached to which letter? Samira? Yeah, so we're going to use this 4 to complete the square with. And that never changes, you guys. That rule will always stay the same. One more time. I'm not really feeling the brackets again. I'm just going to change the color real quick. Because on this gloomy day, the colors are the only thing that makes me happy. Okay, there we go. Question?
For the one with the numbers in front, do you have to divide the x with that number or?
Nope. So look, this is what we do. We take the 4 and we divide it by 2. So 4 divided by 2 is 2. And then we take that number and we square it. And 2 squared is a 4. Now, in this case, it just so happened that it was the same number. It's not always going to be the same. Like in the other example that we did, when we completed this square, we started with a 6, we ended with a 9. In this example, we started with the 4, but then we ended up with the 4. Not always the case, but if it does happen, not a big deal. Okay, so now we're going to follow the same steps as before. We're going to have equal to, I'm going to keep that 3 that I factored out there. And then I'm going to keep this x squared and the minus 4x together. And now, you guys, we take this number that we've completed the square with, and we're going to add it on to this binomial over here. And then what do we do to it out here? Krishna? We subtract 4. And the reason why we do that is because you can't just randomly add a number. You have to balance it out by subtracting the exact same number. But we always add it first, close a rounded bracket, and then we subtract it after. Okay, now I'm going to put square brackets around this entire thing. And then I'm going to finish off the question with my positive 11. So again, if you take a look at this question from the original, have we changed the value of anything so far? No, all we did was factored out the 3, not a big deal. We added and subtracted the 4, not a big deal. We haven't changed anything. We're just changing the form. Okay, keep going. Now what we're going to do is we're going to look at what's happening inside our rounded bracket. I'm going to go over to the side. I'm going to factor it. And if I've done it correctly, it should be a perfect square trinomial. Both of my factors should be exactly the same. So we'll walk through it together. X squared minus 4x plus 4. Two numbers that multiply to give you x squared would be an x and an x. What are two numbers that multiply to give you positive 4? And then, so what are all the factors of 4? Let's just do that. We have 1 and a 4 and a 2 and a 2. Can any one of these be added or subtracted to give us negative 4? Yeah. Good. So we're going to go negative 2, negative 2. And you could just quickly refoil it in your head and see if you get the original. Does this end up working out? It does. So I'm going to rewrite it. So it's x minus 2, all of its squared. And it just worked out really nicely, as I said it always will. Okay, we're going to replace this bracket over here with this term over here. So we're going to have equal to, I guess I'll just keep this little yellow thing, and then I'll replace this. So this is going to become x minus 2, all of it squared. We got rid of the positive 4 because we factored it, but have we gotten rid of the negative 4 yet? No, we got to keep that there still until we deal with it. And then of course the positive 11 didn't go anywhere either. It stays where it is. So really, all we've done so far is we've taken the stuff inside the bracket and then factored it and gotten this. Okay, now if you were wondering, why do we have so many brackets? Why are there rounded brackets and square brackets? In this question, it is important. We have a number outside of the bracket. And now what we have to do is we have to distribute that number to the first term, and we have to distribute that number to the second term. If you're wondering, how do you distribute a number to an entire binomial? The answer is very straightforward. What you do is you just stick them together. You don't have to multiply to each one of these terms. You don't have to do anything like that. You're going to take the 3, you're going to take this bracket, you're just going to stick them together, and then that will be that. So I'll just erase this so that I don't lose space. I'll show you what that looks like. It's going to be 3 bracket x minus 2 squared. Okay, so like nothing fancy. What's 3 times negative 4? Negative 12. We can multiply those. Then plus 11. And then as our final step, we're going to have negative 12 plus 11, which is going to be negative 1. You guys, is this in vertex form? This little term right here? Yes, it is. We can also sketch it really quickly just to see what it looks like for extra practice. So I'm gonna move this over here. What will our vertex be in this question? Severe? Ooh, close. This is your horizontal translation. So it's gonna go positive 2, negative 1. So it's gonna be around there because I'm going 2 to the right, down 1. Is it gonna open up or down? Yeah, there's no negative sign. And the 3 means it's going to be a vertical stretch. So it's going to be kind of narrower. So if I were to draw a sketch, it would look something like this. I can also figure out like what would be the axis of symmetry looking at the equation. What do you think? Amina? X is equal to positive 2. Yeah. And what would be this value, the minimum value? Jordan? Y is equal to negative 1. Good job. I now realize the animals do look like rectangles on the screen, but I promise you on my screen they do not. Okay, so I'm going to start by just rewriting the question so I have a little bit more space. So y is equal to negative 3x squared plus 6x minus 1. Step number 1, I'm going to group the first 2 terms together as I always do. And I want to factor out the number that is in front of the x squared so I can get the x squared all by itself. And when I do that, I am going to get, I'm going to factor out the negative 3. And I'm going to be left with x squared because negative 3 times x squared is negative 3x squared. Negative 3 times what will give you positive 6x? Negative 2x. You got to be careful with that one. As I was walking around, I did see some of you kept the 6 there. Some of you made it a positive 2. So there were just a couple of small errors like that. Just be mindful. When you factor this out, negative 3 times x squared gives you negative 3x squared. Negative 3 times negative 2x gives you positive 6x. So now you've done it correctly. Which one of these numbers are we going to use to complete the square with? Is it going to be the 3, the 1, the 2, or the 1? Yeah, we're going to use whatever number is attached to the x. So we're going to use the 2. I'm going to go over to my side over here. I'm going to go 2 divided by 2 is 1. 1 squared is 1. So the number that we're going to use to add and subtract to this term is going to be a 1. Did you guys get that? Did you get 1 as your completing the square part? Okay, good. So let's keep going. We're going to have equal to, then I'm going to keep the negative 3 outside. So I remember to bring it back later. And then I'm going to rewrite these 2 terms. So it's going to be x squared minus 2x. And now I need to do some special stuff with this 1. So what I'm going to do is I am going to add the 1 and then I'm going to subtract it. So first I'll add it over here. And then I will subtract it right after. And I'll just make sure to just keep square brackets around all of this stuff to remind me to distribute this negative 3 after. It's a little confusing because the last term's a negative 1 too. So I have like positive 1, negative 1, negative 1. Just be really neat when you do these questions. Keep track of your brackets. The messier you are, the more likely you're going to make mistakes. We're going to go over to the side and I'm going to complete the square. So, sorry, not complete the square. I'm going to factor this. So it's going to be x squared minus 2x plus 1. What did you guys get as your factors for this? Anyone get something when you factor this? I'm getting a -1 and a -1. Did you guys get that as well? Yeah. And so it's just all x minus 1 squared. Okay, perfect. So let's keep going. It's going to be equal sign. Keep track of all my colors. Negative 3, square bracket. And now I'm ready to change this into this. So it's going to be x minus 1, all of it squared. Did we get rid of the -1 yet? No. So we got to keep the -1 there. And then there's also a -1 all the way on the outside. So I got to keep all of that stuff. In this step, all I did is I factored and I changed it to this form right here. Samir?
Can you explain this? That's when you did the x minus 1.
I just factored. So simple trinomial factoring, you basically, what two numbers multiply to give you x squared? It's an x and an x. The only two numbers that multiply to give you a 1 are a 1 and a 1. And then you just have to play around with the sign so that they subtract to give you -2. Okay, now what we're going to do is I'm going to take the -3 and I'm going to distribute it here and I'm going to distribute it here. And really, this step is the easy step because you're just taking these two numbers and sticking them together. You don't have to multiply it inside the bracket. That x minus 1 squared should not change. -3 times -1 is +3, and then -1. And now we're finally ready to get our answer in vertex form. It's going to be -3 x minus 1, all of it squared, plus 2. And just to be consistent, we have been graphing or just sketching a graph. So I want to show that to you guys as well. For this question, what is our vertex going to be? Jordan? Yep, so we're going to go 1 unit to the right. We're going to go up 2 units. Is this parabola opening up or down? Down, and there is a stretch, so it's going to be a little bit narrower. So it's going to look something like this. If I were to ask you for the axis of symmetry, what would it be? Severe? X is equal to 1. Remember, axis of symmetry has to be an equation, so you would make sure to write this as x is equal to 1. And if I ask you for it, what is the maximum value, you would say, yeah, y is equal to +2. Yes. So x is equal to 1 is the axis of symmetry, y is equal to +2 is the they're bored and you're like, okay, so for the recording, I'm going to come back to questions 4 and 5. Question 6, however, is not a challenge. We can definitely do this one. So I just wanted to put one example where we're going backwards. We have something in vertex form, and I want to change it back to standard form. Why would I do that? No reason. Standard form is absolutely useless. No, I'm joking. It's not completely useless, but this is an important skill to have. What do you think we can do to convert the vertex form back into standard form? Yeah. It's kind of the opposite, but it's actually even easier than the opposite. This is actually just going to be bed mass. So what we're going to do is, see how it's x minus 2 squared? We're going to write that as x minus 2 times x minus 2 plus 6. Do you guys remember when we learned FOIL? Okay, so we're going to FOIL these two brackets, first, outer, inner, last. I'll do it with you guys. So x times x is x squared. That's the f. Outer is x times -2, which is, and then -2 times x is, and then -2 times -2 is plus 6. Now I'm just going to simplify the bracket. So it's going to be x squared minus 4x plus 4. So do you guys notice that this doesn't complete the square or anything? It's just algebra, right? Like what we learned back in the day. This now is grade 9 stuff where we're going to distribute the -3. So -3 times x squared is -3x squared. -3 times -4x is good. -3 times +4 is plus 6. And then we finish it off with just adding these. That is -6. So this is how you go from vertex form, which is super important and helpful in graphing parabolas, to standard form, which right now is pretty useless to us. We really can't do much with it. But maybe after next week, we'll see that there is a little bit of use to it. Okay, everyone kind of see how we just went backwards now? Vertex to standard. All right, so I'm going to pause the recording. We'll come back to questions 5 and 6. All right, so now that we are all experts at completing the square, you guys have gotten a little bit of practice. Let's just throw a fraction in and confuse everyone. That's the goal of today. No, I'm kidding. The fraction shouldn't scare you. It just adds one additional step to doing these questions. To be very honest with you, fractions are more what you'll see in grade 11, but I definitely want you to be introduced to it. And it's part of grade 10 as well. Some of the textbook questions you do will have fractions in them. Possibly, possibly. Yep.
So are you gonna leave my first formatting? Or just the graph, start how we have to code it?
I hope not, but I think if you do enough questions, you should.
As long as you find it.
Sure. Yeah, as long as the brackets aren't placed incorrectly, like in a place that they don't make sense, it should be fine. Okay, so let's try this question. Just like before, I don't know why I wrote this so far apart. Okay, guys. So just like before, we're going to group our first two terms together. And just like before, I want the x squared to be by itself. So here is basically where we're going to do our new step. In order for me to have my x squared by itself, I am going to factor out a half. Now, the first part of this is pretty straightforward, right? Because a half times x squared is going to give you a half x squared. Here is the part where you're really going to have to think. This is the only part that's different about this. The rest of the question is the same. So one more time, I grouped the two terms together. I want the x squared to be by itself. I factored out the half. We have to try to figure out a half times what number over here, so times some sort of number, which I guess I can call A, has to give me this number over here, which is a -1. So I'll repeat that again. A half times what number over here is going to give me a -1. Now, for some of you who have their hands up, it's probably intuitive. You probably could figure it out. What'd you guys get? Jenna Hearn? Yeah, did you guys get that as well? Yeah. So for some of you, it's like, no, I get it right away. But for others, maybe you need to just see the math a little bit. So I'll show you how I do this. I am just going to use my magic number and I'm going to multiply everything here by the number 2. So half times 2 is just a 1a, and then over here, it's going to be a -2. And so you guys were right. Over here, we need to have a -2x. So a half times -2 is going to give me a -1. Now, you guys, the rest of this question is exactly what we've been practicing all along. That's it. So nothing really challenging except for figuring out this number does require a little bit of thought. Mira?
What is it?
Multiply. So I just called this number over here an A, and I said a half times A is going to give me -1. Then I did my math, which is really just equations. And I figured out if I put a 2 here, a half times -2 is going to give me a -1. So now this question should be pretty straightforward. You can go ahead and try to complete the square. Shweta? You could do that as well. Yes. Yes. Yep. The second question I shall. Yes. Okay, so let's keep going. We're going to have a -2x. Now this step, you've probably gotten a lot better at it. It's going to be 2 divided by 2, which is a 1. And then a 1 squared is going to give me a 1. So what I'm going to do is I'm going to add a 1 over here. And then I'm going to subtract a 1 over here. And then I'm going to put big square brackets around everything plus 3. Question? You wouldn't lose marks. I just think that it makes it easier for you guys, but definitely that's fine. Also, some of you guys are doing the question, you're asking me, do I have to show all my work? And the answer is really you don't. If you can factor this in your head and you can get the answer, by all means do that. If you still need to show your work, that's totally fine as well. X squared minus 2x plus 1. When I factor this, I'm just going to get x minus 1 and x minus 1. So this is just going to be x minus 1 all of it squared. So over here, I'm going to have x minus 1 all of it squared. I didn't get rid of the -1 yet. and the positive 3 stays there. I did those kind of fast, so I'll just pause here first. I'll keep going. Now I'm going to distribute the half to everything inside here. So it's going to become a half bracket x minus 1 squared. A half times -1 is -1/2 plus 3. And then you can just do this little calculation on the side, or if you have 3 wholes and you take away a half, you're going to get 2.5, which is 5/2. So for my final answer, I am going to get, which I guess I'll just write over here, it's going to be y is equal to a half bracket x minus 1 squared minus 5/2. What did I write? Yep, it should be positive 5/2. Up and see what I'm doing. Okay, so for this question, it's the same thing. So y is equal to I guess I'll just go over to the side over here. So -1/3 times what number is going to give me a -2. I can multiply both sides by -3. So a is just going to be a whole number 6. So that means this is going to be 6x. -1/3 x squared is -1/3 x squared. This is -2x, and that's a positive 3, so it works out. Then we need to complete the square. To complete the square, it's just going to be 6 divided by 2, which is 3 squared, which is 9. So -1/3. And then I can just factor this. So it's going to be x squared plus 6x plus 9, which is equal to x and x plus 3, which is x plus 3 all of it squared. So please don't just copy this down, try it yourself, because I'm going to keep it up here and then see if we can get a matching pair of answers or if I've made a mistake. Safir? This, so I did -1/3. I did it over here, -1/3 times what number here, which I called A, is going to equal to -2. Then I used my magic number of -3, and then it just become A is equal to 6. Another way to think about it is -1/3 times positive 6 gives you -2. Yep.
Also, could you just like do like
Divide. Like, could you do -2 divided by -1/3 and multiply it?
No, because like okay, when I did like
Yeah.
1/3, and like the reciprocal stuff, like fraction, like all 1/6, like 6 and 9 basically. So like if I just take it down,
So another way to think about, I wouldn't think of it that way. Another way to think about it is you're dividing this by -1/3 and you're dividing this by -1/3. So you could think of it as -2 divided by -1/3, which is -2 times 3 over -1, which is 6. So that's another way to think about it.
but are you taking like the reciprocal of the other?
You are, yeah, you are taking the reciprocal of this number, yes.
Yeah, I do.
Nope, you're taking the reciprocal of this. You're basically doing -2 divided by -1/3, which is -2 times 3 over -1.
Is that like the regular way?
Yeah, you can show it either way. It doesn't matter which way. You could show it this way or you could do it this way. Either way, you're going to get 6 as your answer. You guys, I'm going to put this up for just another minute and then let's go over what we want to talk about your test. Sorry.